All right, in this video, we are going to work the following problem from our book, and it's problem number 4.24. It says a family is defined to be a group of two or more persons related by birth, marriage, or adoption and residing together in a household. According to the current population survey published by the U.S. Census Bureau, the size distribution of U.S. families is as follows. Frequencies are in thousands. All right, so it says a U.S. family is selected at random. Find the probability that the family obtained has A, two persons, B, more than three persons, C, between one and three persons inclusive, and one person, E, one or more persons. Okay, so um, right, these are frequencies or counts, and so what we're gonna have to do is add all these together, right? And the reason why is because we need to know the number of families in our sample space, right? So we would add all of these together, and I've already done that, and it comes out to be 80505. All right, and now you may say, hey, well, wait a second. This is supposed to be all U.S. families, right? It's a census or whatever. Remember, this is in thousands, right? And so that's not the real number. The real number is 8,505 times 1,000, right? That's the real number right here. But, right, the numbers are really big. They'll just report it in thousands or something like that. And so you may say, well, isn't that going to affect, how I do this problem? But if all of these, right, are reported in thousands, and I'm calculating probabilities, right, then say like this first number up here would be 37148 times 1,000, right? And then the bottom number would be 80505 times 1,000, right? Like so. Okay, if you can multiply the thousands in there if you like, right, and you'll get two really big numbers and then divide them. But if you look, right, these numbers here are both times 1,000. 1,000 is a common factor between the top and the bottom, right? So when we're calculating these probabilities, right, we can just cancel those thousands out, and you can see we get exactly the same number here. So as long as everything's reported in the thousands, we don't have to really worry about that too much. Now, if you are just reporting the numbers themselves, if you go and say, yeah, we counted up all of the families in the United States and there's 80,505 of them, people are going to be going, wait a second, that doesn't seem right at all. There's a lot more people than that in the United States. So if you're just reporting these as, counts or frequencies, then then you probably need to adjust that. You need to either say, that's in thousands, or just report the number as whatever it is, 80,505,000, right? Or 505,000, yeah. So report it that way, okay? All right, so for us calculating probabilities, we don't have to worry about it. We can just do this without multiplying the thousands in there. Okay, so next, so let's go and calculate the probabilities. It says, find the probability that a family obtained has exactly two persons, right? So that would be right here. So the number in our event, right, that a randomly selected family has two people would be this number right here, 37,148 thousands, right? And then divide that by the number in our sample space, which is 80,505 thousandths, right? And so that's the number for part A. For part B, right, they want to know what is the probability that, what is the probability that a giant ruler will come across the screen? So no, more than three persons. So more than three persons, right? More than three would be four or bigger. Okay, so that would be all of the people in this group. So you'd have to add these numbers up. Let's go ahead and do that. So you get 15054 plus 0 plus 2438 plus 1395. So 25,000. 547 all over 80,505. Again, you can just convert that to a decimal by dividing those two. All right, next up it says between 1 and 3 persons inclusive, right? So meaning including the number 3 and the number 1, right? So that would be right here, these numbers, and notice there is no number 1, right? Because by definition, a family is a group of 2 or more people related by birth, right? So that number 1 is not on there. You can just consider the frequency as 0, okay? So we would have to add these two numbers up. Three seven one four eight plus 17810. So we get 54,958 over 80,505. All right, part D, they want to know one person, right? And again, for 1, there's nobody, right? Because a family is by definition 2 or more, right? So that's really easy, right? The number in the event is 0, right? That's the empty event. And 0 divided by any non-zero number is 0. So that basically means that it's impossible for this event to occur. If I randomly select one of these families, what is the probability that they would have a family size of 1? Well, it's 0. So that means it is impossible for that to occur. Okay. All right, and then part E, they want to know 1 or more persons, right? So that would basically be everybody in this table, right? So we would add up all of the numbers in this table, which we've already done, right? We know that that would be the number in our event. And then the bottom number, of course, would be the number of families in our sample space. Right? And here we're dividing the same number on top and bottom. It comes out to be 1, right? And so that means that event is guaranteed. It's certain to happen, right? If I pick a family at random from here, right, it will contain 1 or more persons, guaranteed, right? Because they all do. So, so there we get a probability of 1. All right, and that is it on this one.